what goes wrong at the neuromuscular junction, because when something goes wrong, it actually helps you understand how the entire system functions, all of these various parts. So what I'm going to do, I'm going to tell you what Botox does. You've probably heard of Botox. It's used in spas a lot to paralyze muscles, usually of the face, because then people's face looks less wrinkly. So that's the cosmetic reason for Botox. There's actually a lot of clinical reasons to use Botox. So for instance, there's some migraines that are caused by, we'll learn them later, they're chewing muscles that are attached to your skull, and they will just contract continuously and literally squeeze somebody's head, and it's very painful. So one of the therapies for migraine, some types of migraine, is Botox shots to those chewing muscles. Not enough that, you can really target the injection. Not enough so that, you can't chew. They'll leave enough muscle function that you can do that. But it will relieve some migraines. Another reason to use Botox clinically. Cerebral palsy. Some people with cerebral palsy, it's called spastic paralysis, so they can't really control the muscle, but it's in a permanently contracted state, and it can put their body parts in awkward positions. It's hard to say lay down flat to go to sleep or get into a particular chair depending on the position that they're locked into. So they'll give Botox injections just to loosen those muscles up, and it's less painful. It's also easier to move into different positions, like from a chair to a bed or something like that. So what does Botox actually do, though? So Botox, it is a toxin. The full name of it, it's fine if you just know Botox, is botulism toxin. And so it's not the actual bacteria. Botulism is a bacteria. It's not the actual bacteria. It's a toxin that's produced by the bacteria to really defend itself from, death. So what happens is Botox will destroy the ability for the vesicle to dock and dump its contents. So there's a protein that is involved here, you don't need to know it, that allows the vesicle to dock at the edge here and then dump its contents. So with that mechanism gone, your sender's gone. So botulism targets the sender. And then you wouldn't have anything in the cleft here. And thus the muscle's paralyzed. So the neuron may send the signal, the neuron can't complete the signal. So the muscle never knows that it should move. All right, the other type, which actually I realized I was on the wrong slide. So one other clinical condition, Botox is, I don't know so much a clinical condition, but it's a clinical therapy. This is actually a clinical condition I won't make you spell that because that's hard. Myasthenia gravis. It is a disease. It's actually an autoimmune disease. We're going to see a few autoimmune diseases in this class. I'll bring up at least one more, maybe two. Autoimmune means your immune system, for whatever reason, is attacking your own tissues, which is terrible, really. Autoimmune diseases manifest in a lot of different ways. It depends on what kind of tissue is being attacked. So, for instance, in Chapter 9, which some of you are going to watch later than today, but that's okay. In Chapter 9, we'll learn about a form of arthritis that attacks, or the immune system is attacking some parts of the joint. In this particular case, myasthenia gravis, for whatever reason, the immune system is destroying, I don't illustrate it here, unfortunately, but it destroys the receptor proteins, so the ACH receptor proteins. That's very bad. Oops, that should be an E, sorry, receptors. Because then, in this case, the receiver cannot receive the signal. So in the case of Botox, you had the neuron, the sender, unable to send. And in the case of myasthenia gravis, the receiver no longer has ears, I guess, cannot receive the signal. So two different ways in which the neuromuscular junction can no longer function, both with the same result, paralysis. Usually in the case of myasthenia gravis, over time, you just get weaker and weaker and weaker until there's no more receptors, and for some reason the sarcolemma starts to smooth out as well. That's all you really need to know is right here that myasthenia is an autoimmune disorder. It destroys ACH receptors.